Okay, so today we're going to talk about some different types of quadratic applications. We did projectiles for an entire lesson last time, and now we're going to talk about some of the other different types we see. Projectiles is the main one, that you see. It's the most common one you'll see, but there are different types. So for these, for projectiles, there's always, time versus height. Okay, for these, you're going to have different variables. So the first step you want to do is define your variables, write your equations, figure out what you're looking for, whether it's the x-intercepts, the y-intercept, the vertex, most commonly the vertex, and then solve for whatever you're looking for using, whatever methods you feel appropriate. Whether it's, put it in standard form, put it in factored form, you can graph them. We're going to talk about graphing next. But, whatever form works best to find what you're looking for. Okay. So again, there's no, one game plan for these. You set them up, you figure out what you need, and then, you guys know all the skills by now to solve those problems. All right, so let's get into it. The first one is optimization of area. Okay. So we'll read this problem. We are building a rectangular garden against the back of our house with a fence around it, but we only have 120 feet of fencing available. Okay, so that's probably important. What would the dimensions be, the length and the width, of the garden with one side attached to the house to make a garden as large as possible, and what is that maximum area? Okay, so let's go ahead and start with a picture. Okay, so I like to draw a picture whenever it involves geometry, this sort of rectangle. The key to this is one side is attached to the house. Okay, so there's only 3 sides of the fence because of the 4th side is the house. So that's my house, and this 3 sides it's going to be the garden. So we'll label this as the garden. All right, and we're trying to maximize the area of that garden. Okay. All right, well, what do we know? We know we have 120 feet of fence. Okay, that's your perimeter. So the perimeter is 120 feet. How do we form the perimeter? Well, we have 2 widths here and we have a length. Okay, so the perimeter would be width plus length. Okay, perimeters add up all the sides. We only have 3 sides. Usually it's 4. Okay. Well, I could rewrite that instead of W plus W. Rewrite that as 2W plus the length. Okay. And I'm going to rearrange this because remember, we're not supposed to have more than one variable. So I'm going to solve for L. Subtract the 2W over. And with that, I could replace the length with 120 minus 2W. Because again, we could only solve equations with one variable. Okay. So we had to get it all in terms of width. All right, so we're maximizing area, so we need an area equation. Okay, area is length times width. Okay. I know the length. Well, I know an equation for the length. 120 minus 2W. Okay, again, that's because there's 120 minus the 2 width sides is going to be your length. And then W is just the width. That's my equation. Okay. It doesn't look like a quadratic equation yet, but we're going to change forms and put it in standard form. But that is the quadratic equation we're going to use, and that's the quadratic equation we're going to maximize. So the whole part of maximization, the maximum amount of quadratic is always the vertex. So that's what we're going to find. We need to find the vertex. So I'm going to distribute the W, 120 times W, 2W times W gives you 120W minus 2W squared. And I'm just going to flip the order of that to put it in standard form. So now it's in standard form. Label what A is, label what B is, label what C is. C is 0. A is -2, B is 120. We need to find the vertex. To find the vertex, you're going to have to find the axis of symmetry, which is the x value of the vertex. Opposite of B over 2A. So that's going to be -120 over 2 times -2, which is -4, of course. And -120 over -4 is 30. Okay, well, what is 30? What is the x value of the vertex? The x value of the vertex is W. That's your width. So our width is 30 feet. Because that was the only variable we had left, so it had to be the width. So we know the width of the garden. The width of the garden is 30 feet. Well, if we know the width of the garden. We know the length of the garden because the length is the equation involves width. It's going to be 120 minus 2 times 30, which gives you 60. So we just found the dimensions of the vertex. We found the dimensions that's going to maximize our equation. It's going to be a 60 by 30 foot garden. The second question, that was the first question that was asked. The second question asked is what is the maximum area? So we're going to find the y value of the vertex. To find the y value of the vertex, you plug in the x value into your equation. So negative 2 times 30 squared plus 120 times 30 equals 1800. Now notice we didn't have to actually do that step. We could have just done the dimensions because we know the area is length times width. We knew the length, we knew the width. We could have just done 60 times 30 to give you 1800. So either way works. All right, and that's 1800 feet squared area. And I'll label feet and feet for width and length. And that's that problem. Okay, another common type of problem is to maximize profit. Just like maximizing the area or optimizing the area, you're going to be looking for the vertex. The vertex is always going to be the highest point, the maximum. So in some cases, you're going to be just given a profit equation and you're trying to maximize that profit. So this is an example of that. Again, it's going to be very similar to the last one, even a little easier because we don't have to write the equation. The profit from selling local ballet tickets depends on the ticket price. The profit can be modeled by the function p of x equals negative 15x squared plus 600x plus 60, where x is the price of the ticket and p is the profit. What price will give the maximum profit and how much will that profit be? Okay, so like I said, you don't have to do as much work for this one because we already know the equation. Okay, the last problem we had to find the equation, write the equation. This one we know the equation. So if we want to maximize the profit, we're just going to be looking for the vertex again. So we already have the standard form equation. We'll label our A and B and C value. A is negative 15. B is 600. All right, B is 600 and C is 60. Okay. What we're trying to do, we're trying to find the vertex maximum. So we're going to have to start with the X value of the vertex. The X value of the vertex represents the ticket price of that maximum profit. So opposite of B over 2A, negative 600 over 2 times negative 15, gives you a ticket price of $20. Negative 600 divided by negative 30. All right, and that's the answer to the first question. What is the price? What price will give the maximum profit? That's the price. All right, the second problem is how much is that profit? Okay, that's going to be the Y value of the vertex. The Y value of the vertex is going to represent the maximum profit. All right, and to find that, we're just going to plug in 20 into the equation. So negative 15 times 20 squared plus 600 times 20 plus 60 gives you a maximum profit of $6,060. 6060. That is the maximum profit. So you sell $20 tickets, you're going to max out your profit at $6,060. So like I said, those are kind of easier than the previous ones because you're given the equation instead of having to write the equation. The last type of problem we're going to do is, I call them increase-decrease problems. They're also just maximizing profit or maximizing revenue problems. But you know, it's a very special type. This one's probably the hardest type you'll see. So in this problem, let's read through it. A popular designer purse sells for $500 and 45,000 are sold in a month. The company did some research and realized that for each $20 decrease in price, they could sell 5,000 more purses per month. How much should the company charge for the purse so that they can maximize the monthly revenue? All right, we're going to have to start this problem by figuring out how to calculate revenue. Revenue of something is going to be equal to the price times the number that's sold. So revenue is price times the number sold. In this particular problem, we're given a base price and we're given a base number sold. Right now, the purse sells for $500. That's your price. And right now, they're selling $45,000 per month. That's your number sold. But then that research comes in. They realize that for each $20 decrease in price, they could sell 5,000 more purses. Okay. So the price is going to decrease while the purse number is going to increase, hence the increase-decrease problems. So what's our variable? Our variable, we're just going to call it x. The variable is the part that changes. The part that's changing is the increase and the decreasing. So we're going to let x equal the number of decreases in price. Okay, so the number of price decreases. That's what x is. So each time you increase it, or each time you decrease it, the price changes and the number sold changes. So we have to reflect those changes in our equation. So we have the 500, that's the base price. Okay. Every time you decrease it, so each x is going to decrease by $20. Okay. So the price is going to be 500 minus the $20 decrease times the number of price decreases. So if you decrease it 3 times, you're going to decrease, the price will decrease actually $60. Okay, so 500 minus 20x. All right, how does the number sold change? Well, you have the 45,000, but each time there's an x, each time there's a decrease in price, you're selling 5,000 more purses. So this is your increase. This one's going to be plus. So it's going to be plus 5,000 times the number of price decreases. So again, for example, if you decrease the price 3 times, that's going to increase your purses sold by 15,000. So we represent that with 5,000 times the number of price decreases, which is x. So again, these are kind of difficult. That's your equation. Okay. Now we're trying to maximize this equation. Okay, first, let me label this. So revenue, we'll label that R, and our variable is x. So we'll write that as R of x. So R of x equals that equation. We need to find the vertex of that equation. Okay. Right now, we'd have to FOIL this. Okay, so to find the vertex, we'd have to FOIL, put it in standard form, find the vertex that way. That's going to be a lot of work. So right now, we're just setting up the equation. Next lesson, we're going to graph it using some technology, and we're going to solve it graphically.